This question here doesn't mention anything about internal resistance, but this is an internal resistance question. And what we're supposed to assume is that this isn't like an old broken battery or anything. This battery is still capable of putting out 6 volts. And that if it's putting out less, then that's because there's a voltage drop inside the battery due to its internal resistance. That voltage drop, which is the difference between 6 and 5.17, is the current that's going through, well, any part of the circuit and the internal resistance. But yeah, what I'm seeing is what we can do, which is to find the internal resistance, and then maybe that'll help us out going on from there. And we found it, and I'm going to go ahead and label that as the internal resistance over here. Now, as we have more current going through, that internal resistance doesn't change, but it does increase the voltage drop inside the battery. So we're going to read even less voltage outside when there's more current going through. The internal voltage drop would be 1.24 volts with our higher current, which would leave us measuring only 4.76 volts outside the battery. That ought to really help you out with one homework question. And I got a hint for another one that relates to internal resistance. And that hint is that when you're using a voltmeter, you can assume that no current is going through the voltmeter. And when you're using an ammeter, you can assume that the resistance is negligible. The resistance that the ammeter has. Okay, here we have 3 capacitors with equal capacitances. They're connected in series, and they're charged by a battery. We got to find what is the capacitance of all these. So the first thing to understand is that each of these capacitors is going to hold the same charge. So the battery pushes charge into the first plate. The second plate gets the opposite but equal charge, and there's no choice but for the same charge to appear here and here, etc. And the second thing to understand is that the sum of the voltage drops over each of these 3 capacitors is going to equal the 7 volts applied by the battery. So the voltage drop over any one of these, and it's handy that they're all of equivalent capacitance, is 2.34, which is a third of 7.01. And then we just have to remember that capacitance is the charge that gets put on the plates per voltage applied. So we just divide the charge by the voltage on any one specific capacitor, and we get this value. And it is reasonable because the normal capacitors you see that you're going to be using in electronics usually in everyday life are pretty significantly less than 1 farad.